Let's welcome our next speaker. Alissa is the R&D manager at Kiali, Istio, the observability open source project at Red Hat. She hails from Israel, and we did a short walk around the city with some of the other speakers last night, and she mentioned how similar parts of Plaka are to parts of the city that she lives in. Welcome to Athens. It's always good to welcome our cousins from across the sea, and big round of applause, everyone.
Please let me know if you hear me well. Raise your hands. Raise your hands if you hear me well, or if we need the volume adjusted. Yeah? Only 50% of the people can hear me well? That's a challenge. All right. So thank you very much for coming today, and thanks to the conference organizers for having me here. I'm Alissa. I'm an engineering manager in the Kiali project at Red Hat. And today I would like to talk about service mesh. What service mesh is, why would we need it, and how Istio and Kiali open source projects can help manage it. And as you probably noticed, those are Greek words inspired by the maritime world, and so I find it extremely awesome to have this talk here in Athens because of that. Before we dive into what service mesh is, I find it important to spend some time talking about the evolution of how did we get to the point that we need a service mesh. And at the beginning, until a few years ago, we had a lot of monolith applications. It was a single process or a single unit of executable where we would take all of our code and put it together inside. So we had to build it together, ship it together, deploy it together. And if we look closer, there are different application modules as part of this. A typical application would look something like this. We would have a module for alerts, for reports, for data processing, something for UI, and so on. And at times, different parts need to be scaled differently. They need to be upgraded at different times. And that was a challenge with a monolith. So in order to solve this challenge, a separation began of those services to separate ones to run independently, each in a single process. And now we got a suite of services which were communicating through network, typically over HTTP with some resource API. And this is what is called today microservices. So we got services that are scaled separately, upgraded separately, and they're also language agnostic. So every team can choose their own technology with which they would like to develop their part. Now, along with that, there was another move that also enabled this part, and that was a shift in application packaging and runtime. With the rise of Docker a few years ago, it became much more approachable and accessible how we can containerize an application. Or in other words, how we can create a container image and then spin up containers of that image. But running multiple containers on their own, it's not enough. It's a great ability. But we need to orchestrate them. So we need to run many containers on multiple hosts. We need to scale them and manage those replicas of our container. And we also need to manage the environment on which these containers are running. And in order to help to achieve that, container orchestration platforms were created, such as Kubernetes and OpenShift or OKD. And I would like to spend some time on discussing some of Kubernetes building blocks that are important for understanding of service mesh later on in this talk. So a pod is a group of one or more containers, and they share a storage and network. And it's also the smallest unit through which we can manage this resource with Kubernetes. We cannot directly manage a container with Kubernetes. A deployment manages the pod definition, which container images we would like to have as part of it, and it also defines how many replicas of pods we would like to have in runtime. Kubernetes service is an interesting abstraction. It is actually an access point to that set of pods, and it's sometimes called a microservice. Despite the fact that Kubernetes service does not hold itself our applicative code, the pods hold it, it still serves as an access point and represents them, so we call the Kubernetes service a microservice. And this is how the microservices would look in the Kubernetes way. So we have service B and service A. Those are Kubernetes services. They serve as access points. And then behind them, there are the pods and the containers. In this case, in this example, there are 2 instances of the pod. in this case 1, and so this is the representative microservices. And those environments now are highly complex. We have sometimes hundreds or thousands of services running. So we have a lot of services that we need to keep there if they're up or not. We have a lot of network requests now, and we have to keep different replicas of this system. And now we also get multiple points of failure because we have a lot of network, a lot of parts can be down, and so on. So here are my challenges in this containerized environment in the moment. How do I route requests because we have much more network calls than we had with the monolith? How do I detect failures and downtime? And how do I upgrade and deploy newer versions of the service and do not cause downtime to the system at the same time? And also security sometimes matters a lot, so I would like to secure the entire system and the communication between the services. And this is where service mesh came in to solve those challenges. And so what is a service mesh? A service mesh is an infrastructure that handles the communication between our microservices. And from a technical aspect, it's often implemented as a set of network proxies that are deployed alongside the microservices. And Istio is an open source service mesh, which is very, very popular these days. So we'd like to spend some time talking about that. And it provides us with a lot of handy features, such as load balancing between different replicas of our service, traffic control, defining routing rules, retries, fault injection, which I would show later on, mirroring, securing the communication on different levels can be done with Istio. There are metrics and traces to all of the traffic that's collected and stored, for example, in Prometheus. And this is important terminology that's used both by Istio and Kiali, and it's important to kind of go over it. So workload is anything that is owning or controlling pods, like a deployment. It can be a pod itself when it's not backed by a deployment. A service is a microservice or a Kubernetes service. And there are two textual labels, Kubernetes labels, which are extensively used by Istio, and that's the label app and the label version. And it allows us to distinguish different versions of the same service. So if I have two versions of my service running on a system, I will have the same label app, but a different version tagged on each. So before Istio, but with Kubernetes, we had the following structure. We would have a pod. Inside, we would have a container or more than one. And we would have our business logic code. And then in addition, we also needed some handling code for routing, circuit breaking to guard our application with a connection pool, and more. And then in every pod and in every container, we had to repeat a very, very similar logic, and any change in routing, any change in circuit breaking required us to rebuild and redeploy our application. And Istio provides us with a way not to do it this way, so we can take this code out and actually make an external and configurable part which can be managed through Istio. And that is achieved with the help of a sidecar proxy, which is deployed next to each instance of the microservice. It is transparent to application code. The application is completely unaware whether the proxy exists or not. It can be also automatically injected to pod on creation when the pod is deployed, so users don't have to manage it manually. And the currently used proxy with Istio is Envoy, which is also an open source project. So now we have a slight change in architecture in microservice deployment. So the routing and the circuit breaking code are gone. They're not part of our application anymore. And now we have an additional container injected to our code that's going to manage this thing. And this is how it now would look with service mesh with Istio on top of Kubernetes. We will have a lot of pods. In every pod, we're going to have a sidecar container. All of the traffic is going to be intercepted by those proxies. So for example, if I have the container in pod A, we would want to talk to this part. It will go through the proxy to this side proxy and here. And the configuration that the proxies are getting is completely transparent to the application. We can change it at any time, and it immediately is sent to proxies, and the application runs as usual. We don't need to rebuild it or anything like that. And now I would like to go a little bit about different routing scenarios that Istio allows us to do. So A/B testing is quite a common technique where we're sending 50% of traffic to one version of a service and then the other 50% of traffic to the second version of the service, and then we can compare. Canary deployment is another case of testing a newer version of our microservice, and it's also an example of traffic shifting, and I will go into this in a minute. And mirroring traffic is a very nice way of testing also a newer version of a service. So this is an example how A/B testing or weighted routing, because we're putting weights on 100% of the traffic, and we're kind of dividing that. In this case, I'm sending 50% of the traffic to version 1, which has 2 instances, and 50% of the traffic to the same microservice and its version 2. And what's interesting to note here, and it's important, is that the proportion of the traffic that's routed is independent of number of instances, because version 1 has 2 instances, and it receives 50% of the traffic, and version 2 is receiving 50% of the traffic with only 1 instance. Now, with Kubernetes, we had to have this proportion aligned. Canary deployment is another way to test a service, and in this case, we choose to send a very small proportion of the traffic to the newer version. In this example, 10%. And then gradually, when we see it's working fine, we're going to shift the traffic, send more traffic until we reach all the traffic sent to this one. And of course, we would like to scale it as well. Matching routing is another technique how we can do routing with Istio without setting weights to traffic. So I can do matching condition based on which the routing will occur. In this example, I can define a header. If there is a header with user Alissa in the header, it will be routed to version 1, and all other users are going to be routed to version 2. I can, of course, do it with different conditions. I can say something like user agent for browser type. I can define it on different HTTP methods. Get goes here, post goes there, and so on. Mirroring traffic is a very handy and interesting feature that Istio provides us with. So sometimes we would like to experiment and get a bunch of real traffic and run some tests, but we don't want to interfere with how the real application is currently live and running. So all the traffic, when we define mirroring, is copied by Istio and sent to the version 2 in this case. And what's interesting to know here, I put this error one-sided on purpose because the response from the mirror traffic is disregarded, so the original caller will never receive it. And quite often, the happy path of applications is tested. And also, each microservice is tested separately. And then we arrive to production, and we have all of this integration and reality bites, or as Murphy's Law is saying, anything that can go wrong will go wrong. And in order to help us to still succeed with this integration and have the system up and running with minimal failures, or at least that we anticipate those failures and we can fix them in time, we get something that's called chaos engineering. And chaos engineering is a technique through which we test the resiliency of our application by intentionally causing breakdowns and failures to different parts and seeing how the system handles it. And Istio provides several features which make chaos engineering much easier to do. So we can simulate network latency or an overloaded service by injecting a delay to a service. And we can also simulate failure of a service, simulating that this service is down, when in fact it actually isn't. By returning a predefined HTTP error, we can do it for all of the traffic, we can do it conditionally, and it's a very good alternative to just manually killing the pod, scaling it down, and so on. Sorry. So this is an example of an injected delay. I'm going to inject a 7 seconds delay to service B. So any caller will get the real response time plus the 7 seconds delay. And in this example, the error injection will work, but only for user Alissa, and the rest of the users will not notice anything. And the service is in fact up. Circuit breaker is a way to guard our application by defining a connection pool. And outlier detection is a good way to classify different instances of our service as healthy and unhealthy. So unhealthy ones can be ejected and then brought back to the pool later on. There are several important features for security that Istio provides us. So in and out of traffic of the mesh is disabled by default, and we need to define gateways to allow that. Mutual TLS can be defined on multiple levels for the entire mesh, for single service, on a namespace level, and so on. And there are several authentication and authorization features. So there are different configuration objects to which this entire thing can be configured with Istio. So a virtual service is not a Kubernetes service. It's rules for how requests for service are routed. Sorry. And we can define chaos injection through it. A destination rule is defined for when the traffic already has occurred after virtual service configuration was applied. And we can define through it circuit breaking, load balancing through instances of the service, and so on. There are several additional interesting objects. I invite you to check them out later. And this is an example of a configuration YAML. All of the configuration is done via the YAML files. And all Istio objects are treated in Kubernetes as CRDs, which is the custom resource definition. It's a way for defining custom objects in Kubernetes. So we had the monolith. We broke it down to microservices. We run it in containers, and we have a service mesh. And now we get a new set of challenges, right? Istio itself doesn't have a user interface, and I would like to have some visual cues about what's going on with the system. Is there any traffic? Have I configured routing for service B? Is my configuration even valid? Do I have security on? And so on. And for that, Kiali was created. And it's an open source Istio Service Mesh Observability console. And Kiali provides a set of very handy features for visualizing mesh connections. There is a topology graph, which shows us the relations, which service is calling which. We can see different versions of the service. We can see percentage of traffic flowing to each, and a lot of things. I think I can do a separate talk just on the graph itself, but we don't have enough time for that today. We can also visualize security configuration. There's a health calculation done for metrics aggregated on different levels. You can define routing through UI and not through YAML file. It's more user-friendly. Validation is done on the objects. There are some base validations that are done by Istio itself, but Kiali provides an additional set of validations. Sometimes cross-configuration conditions are analyzed in order to provide this type of validation. And there are metrics and traces thanks to integration with Jaeger and with Prometheus. And I would like to show a short demo. And the demo is based on the book info example. This is a very simple polyglot example application that's shipped with Istio. And as you can see here, the reviews has 3 versions. And each part is written in a different language. So this is the overview page. And this is the rating service. In my case, there are 2 versions of the rating service. And now through a YAML file, I'm defining a predefined error that's going to be injected. So a single user, which is going to be logged into the application, will see this error, and the rest of the users will be unaware of this. And this is an example of chaos engineering. So virtual service and destination rule were created here. And as you can see here, the condition is return 500 error in 100% of the cases, but only when I have a header that equals user Alissa. And this is valid to V1 subset, which is version 1 of my microservice. Now let's go back to the graph. Now we have a visual cue on the rating service. That the configuration has been created, and this is the UI of this example application. And I'm going to sign in as some user, and the expected result is that there's not going to be any error, and the user is unaware that there's any problem. So we're getting stars for the review service, depending the color of the stars, depending which version of the microservice is called. And as you can see here, the user Alissa, when I logged in, the rating service is unavailable because it's returning 500 error. As you can see also, the colors here of the traffic became orange because small proportion of the traffic now is getting failures because of my login with user Alissa. You get still a lot of traffic as okay, 200, but some traffic we're getting with red or with orange, depending on the percentage that's coming from different versions of the review service. And now we can also delete this configuration. And I'm going to log in again with user Alissa, and everything is gone. We're back to normal. You can see everything is very quick, very instant. Okay. Now I would like to show another short demo of how routing can be managed. So in this example, I'm looking at the review service, and it has 3 versions, and without applying any configuration, there's default routing applied, which is approximately 30-something% sent to each version, quite an equal distribution. And I want to change that. I want to play with Istio, and I want to set different percentage of traffic. And Kiali provides with a very nice wizard to do it. We don't need to do it via the YAML file. And I've chosen not to send any traffic to V1, so 0 traffic to V1, 50% of traffic to V2, and 50% of traffic to V3. And also I'm going to apply security. So anyone who talks to the service needs to go through mutual TLS. Again, virtual service and destination rules were created. Right now they're containing different content. We can see the weights here. And we also can edit it via the YAML file for more complex things. And in this example, I'm also invoking the, the validation. So I try to set traffic to be more than 100%. And in this case, of course, I cannot do it because then the system will be broken. Now going back to the graph, we have a slightly changed situation. We have security on V2 and V3. We don't see security on V1 because we defined no traffic, and the traffic is gradually shrinking here. So as you can see, the numbers are going up for V2 and V3, and they're really shrinking for V1. And this is another way to define routing with matching. I'm just going to briefly show the wizard, but not how it's applied. We don't have enough time today. So I can say that user Bob, if I have a header with user Bob, is going to be routed only to version 1. Okay, so we saw several features of Kiali. We saw the overview page, which provides us with cards that define per namespace in different constants the health. We can look at see it for services, for workloads, and so on. The mesh topology graph, I really invite you to try it out. It has a lot of different interesting features. And then we also have runtime metric dashboards. We can have metrics tailored, for example, specific metrics for JVM or specific metrics from Tomcat. Configuration validations, there are different configuration validations. Our website lists all of the validations that are made, and we're constantly adding new ones. Security can be visualized right here. For example, we have mesh-wide indication that security is switched on for the entire mesh. And here it shows that it's also valid for every separate namespace. Integration with Jaeger is done so we can see traces per each microservice in the system. And it's also integrated now in the UI. And that's it. And since both Istio and Kiali are open source projects, I really invite you to try them out. We have a website, Twitter, the code is on GitHub, and please connect, ask questions, look at our demos, and I hope you enjoyed. Thank you very, very much. Fantastic. It's a great question. So both of them are new projects. I didn't mention the history of the projects. Istio was incepted about 2 years ago, and Kiali started last year around February. I know some companies started to try it. Istio has released version 1.0 in July 2018, and actually last week, Istio 1.1 was released. So they definitely say it's production ready. Kiali itself is following Istio. We try to be supporting the latest version as possible. So you can try it out as well. Regarding metrics, there are different types of metrics which are collected, and there is a part in architecture in Istio where Istio is, you can write an adapter. So there's a default adapter where the Prometheus is holding the metrics. And the proxies are reporting before and after every request different types of things like response time, response code, and really there's a lot of metrics. I think a lot of them are documented. And there are also some tailored metrics that can be added as well. And as I said, Prometheus doesn't have to be the backing. You can add adapter. And for example, API management, you can write adapter for an API management and put their specifically tailored metrics.
So does routing handle situations for stateful services? I think that's the next question. Does the routing handle sessions for stateful services? Who's made that question? Does anyone want to?
Yeah, can you clarify, please?
Can you clarify? Where's that hand? Raise your hand. That just came from the cloud somewhere.
Okay, so please, please approach me afterwards. I need to understand better what is the question.
Same user. So we're talking for a scenario where for a specific session, I want it to be persistent across multiple paths. So I've got various routing scenarios across nodes, and I want one session to always be served through a specific path. So
okay, so you can define matching routing on specific conditions. I mean, I don't know the bigger picture for your application.
Using something like headers in that instance.
For example, but not only headers. I showed headers today, but there are different types of matching. You can do headers into...
Thank you.
So I have no idea what you guys are talking about, but then again, I'm good at this, I'm not good at that. Alissa, thank you so much
Please feel
for
to
your
approach me during the break
for
if you
your
have more
fantastic
questions.
talk.